what are the tidbits here and there and what you need to understand going forward. And all the way at the end, I'm going to explain, what certifications you can actually, achieve in this to be able to understand more of AWS going forward in future, and what are the course materials that you can, read up and try to understand AWS even more depth. So that's the way that I'm going to be taking this whole session today. So I'm going to go to the next slide. All right. Now, a bit of an introduction. And again, I'm not going to go too much into it because obviously most of you are from the computer science background. So I assume that most of you are aware of it. So the way cloud computing works and what it is that it's basically, using servers on the, on rent, essentially online. So previously you used to have these server boxes on which you used to host these web applications and all that. And now you don't need that anymore. So basically companies like Amazon and Google, Microsoft, so they rent you all these servers on the cloud, and you basically don't have to care about the hardware. So now you as a startup don't have to care about hardware at all, and all you care about is basically just create your service, on the cloud and just run your application, and you just pay for what you use, rather than buying the whole hardware and realizing that the startup didn't work out and then having all of that hardware with you. So that's the beauty of what cloud computing is. And basically, the important thing is that you don't have to worry about the virtualization part. So previously, when you had to buy a server, you had to create VMs and all these things on it. You have to have a hypervisor or whatever, which can basically, it's the software that allows you to do virtualization on top of your hardware. So all of those things which you used to have back in the days, you don't need all of that anymore. It is all hidden away from you. So all you care about is you just create your server, you create your databases, you connect things with each other, and your application just works. So that's the easiest way of how I can explain what cloud computing is all about. Now, before I proceed further, I actually forgot to say just some housekeeping stuff. So if you have any questions, please feel free to ask. I'm happy to stop in the middle. Just please feel free to ask. I will ensure that the whole session finishes within the designated time. But just if you have questions, please straight away just ask me that. And remember, no question is a dumb question. Every question is important. So yeah, feel free to just stop me in the middle and ask. All right. Going to go to the next slide. So what are the advantages? Obviously you don't have to guess capacity anymore. So in cloud, you don't have to be like, I'm just going to buy this amount of server and all that. So you don't have to do any of those things. You just basically decide right in the beginning that my server, the EC2 instance that I need to create, that's my server. I need to create it with 2 vCPUs or 8 gigabytes of memory right in the beginning itself. You just create that straight away. Now, in the middle of things and how your, say, for example, your customers, all of a sudden you're flooded with all the customers on your website, you can just basically increase that capacity. So you don't have to, buy things, or you don't have to, sort of invest too much of things right in the beginning, or invest too much of money right in the beginning. You can always sort of go along with it, and you just, basically use what you need. And another important thing is the agility that it brings up. So again, I'm going to show you guys some of the, the infrastructure as code that these days people use. And that is something that every company uses these days by services such as CloudFormation and Terraform. So these days, you don't have to just go on the UI and create servers by clicking things anymore. So basically, you create your code using Terraform, and CloudFormation, and you just deploy that code. So this way, say for an example, you've got about 100 places or 100 different environments here that you have to deploy the application on. You can just basically create the code for it and just deploy it in every environment. And you don't have to click on every single one of those and create those 100 environments by hand. So that's the beauty, and that's the speed that it sort of that cloud provides you. And let me just move on to the next slide. Another important thing is the 5 pillars. So anytime you build any application, and again, these are very important concepts to understand. And I know it is theory, but it is very important to understand when you talk about building applications on the cloud. When you get any sort of like a project or something that someone wants you to build some application on the cloud, you always remember you follow these 5 principles, which is operational excellence. So you ensure that you have your monitoring systems in place. You don't just build application and not have any alarms or CPU and memory to sort of tell you straight away that something is actually wrong on some of the servers. And similarly, you also got to make sure the security of it. You got to make sure that you don't use root user for everything. You use IAM users or IAM roles, which provide you temporary access to things. Then also the reliability side of things. You ensure that your workload also is prone to errors like your failures. Like, say, for an example, AWS has availability zones. So that means those are the data centers on which your data is hosted. So if one of the availability zones goes down, you need to ensure that your workload is spans across all the different availability zones or regions in some cases, so that anytime any data center goes down, your application never gets affected or your end users never see that problem. And then the performance efficiency pillar. So you need to ensure again is that whatever you're doing, the way that you're building, is that efficient or not? Whether your traffic, say for example, your traffic needs to go outside to the internet, should it go through like a central VPC, or these spoke VPCs in a hub and spoke model, like the customer VPC or whatever you deploy in. So sometimes, some applications have their own VPCs. Sometimes in some organization, the companies like to keep everything just under one single network. So again, you need
So,
to decide at that time
Aditya, can
what's
you
the
just
most.
tell us what's a VPC? Can you elaborate on VPC?
Yes, sure. So what a VPC is basically, again, it is in one of my future slides. But what it is a virtual private cloud. So it is basically your network on which you host you create your servers on, or your databases on. So say for an example, tomorrow someone comes to you and says that build me an application on the cloud. The first thing that you would do is build a VPC, because that's your network. So on that you provide a network address space like 10.0.0/16, and then inside that you create subnets. You create these small address spaces like public subnets, private subnets, database subnets, and on these subnets is where you keep these applications on. So if you have, say for example, you're building a server for a WordPress website, you just want to, you know say for example, host like an e-commerce website or something, you would build that on EC2 instance. That EC2 instance you will create in a private subnet in that whole VPC. So basically it just gives you a, like a network space essentially. And once you create that server on that private subnet, it will assign you an IP address, right? Now at that time it will be a private IP out of that VPC that you would have built, so 10.16 or whatever. So now you can imagine, just like this VPC is built for that one single application. So in an organization, if you've got about 20 different applications that's on there, every application will have its own VPC. And all these VPCs will be connected to each other. So in case you want to connect from one to the other, you can always connect that. So that's basically what a VPC is.
Yeah, thanks. Mhm.
No worries. And again, the final thing is the cost optimization. So you always ensure that the things that you're building is always under budgets. Now, in this is a very big topic in itself, the cost optimization bit. But one thing that I can suggest you is that any of you opens an AWS account and tries to build something, I would suggest you guys to set up a budget. So if you go to the account section in your in your AWS, the AWS account. So in that, there's an account section right up on the top right corner. So if you click on that, you would get an option to set a budget. So say, for example, you set a budget of $100 or $500 or whatever, and then set an alarm on top of that. So it will tell you straight away and send you an email saying that you are almost approaching that $500 mark. So this way you ensure that, by mistake, you haven't created a service and all of a sudden you get a bill of $10,000 or $1,000 right at the end of the month. So this way you make sure you're always under those, the cost thing. All right, perfect. The next thing is the different AWS services. Now, previously in the traditional organizations, you used to have these, for everything that you need. As an example, for servers, if you need to, have a bunch of servers, so you would, obviously buy a bunch of servers, and then you would buy a software like VMware, which you would use for the virtualization part of it. Then you would have to reach out to another vendor for the, say for example, you want to build something like a messaging protocol. So you would need some sort of a MQ. MQ is basically used if you have like a pub sub model in which you've got one side of things as the publisher, the other side is the subscriber. So it sends messages and the other application has to pick those messages. So what you can understand is that the main thing that I want to talk about is that all these different services that you used to have back in the days will require you to go to different vendors, right? So you'd set up a contract with that vendor, you would get the application from them, and then you would set up your system. So your application would compile or comprise of all these vendors all together, and then you had to set these contracts up with all these vendors separately and then make sure your application just works. With
Yeah,
AWS,
yeah,
you get
Aditya,
all
can
those
I
different
just
services under one
interrupt?
single pane.
Yeah,
Yep, sure.
Aditya, I remember the days when I was having serious negotiations and haggling with Oracle because they had some very peculiar licensing policy, and it was so difficult to deal with that company, and they somehow used to
Yep,
squeeze the maximum dollars from you. Okay, but now I think the pricing is more transparent, and I
100%.
think that's the main reason why people adopt cloud, because it's published and it is transparent and it is available real time.
100%. I think you hit the nail right on the head. So if you see that you had to, for database part, you had to reach out to Oracle, you had to set up a license with them, and their pricing structure is never straightforward. So it's not like it's available on the internet. You can say that, oh, for these many hours, I just pay that much. It is all private. So you have to go to them. They will send you a bill or they will send you an exact quotation for whatever. And then eventually down the line, when you become more and more dependent on their software, they will try to increase the price and you are sort of locked into that. With cloud, you don't have to do any of those things. So with cloud, everything is transparent. You basically pay for what you use. You've got a service. If, say, for an example, you need a database, fine, you go to the database service in the same AWS. You take, NoSQL databases. If you need a NoSQL database, you go to Amazon DynamoDB. If you need a SQL database, you go to Amazon RDS. You need something else, you go Redshift. You do all of these things. So you can see that basically all these vendors, now it's not applicable for you anymore because you just have one single platform which basically gives you everything. You need something related to directory services, which Microsoft used to have Active Directory on. You just go to AWS Active Directory service. You don't have to separately reach out to Microsoft to get a separate, license for it. Then you need a server, just go to Amazon EC2. You need serverless side of things, you go to AWS Lambda. So it makes that process very, very easy under one single pane. You basically get everything that you need. All right, perfect. So let's move on to the next part, which is compute. Now I've got a demo about compute, which I'll obviously go through in a minute. But the main idea with compute is that there's two important services with compute in AWS. One is Amazon EC2, and the other one is AWS Lambda. Now both these services are exactly polar opposite of each other on what exactly they do. Um, what Amazon EC2 does for you is basically your server. So essentially on which you host your application. So you need a Linux server, you need an Ubuntu server, you need a Windows server, you need whichever OS server that you need. You just go to Amazon EC2, you put your application on it, you copy your application code on top of that, you create an Apache server or something to serve your web app or web application, and you basically then serve it out to the world, and then you can basically host your application on that EC2 server. So that is exactly what an EC2 is. So you can see that it's basically a virtual computing environment, and it's something called as instances. So we call it EC2 instances in the cloud in AWS, and it uses something called as AMI. Basically, AMI is nothing but your OS. So you need a CentOS AMI, which basically would be the image that it creates using that CentOS OS, and then using that is what you build the EC2 server with. And again, I'll show you how to build an EC2 server as well, so it makes sense to everyone. And then when you create an EC2 instance, at that time you would choose your configuration of CPU and memory that you need, storage that you need, all of those information, and then you just create it and then host your web application on that. The other one is AWS Lambda. Now, this is the new cutting edge stuff. I mean, again, it's been going on for a while, but more and more companies are actually moving towards that. And now some of the companies with EC2, and again, EC2 now is getting a little bit older in the sense that previously whenever you used to have to create these EC2 instances, you also had to manage the patching. Because say for an example, the OS moves from time to time, there's always obviously these new threats that come in. And to resolve those threats, people or the companies create security patches and all that. So imagine you've got about 1,000 EC2 instances in an organization, which is very normal, and you need to ensure that all of those 1,000 EC2 instances are patched up to the latest security updates. So you need to have an extra service on top of that, or build the extra infrastructure on top of that, to then go ahead and patch all of these instances to ensure that all these security, loopholes are filled up. So you can imagine how much cumbersome that makes the whole process. So which is why the organizations are moving more towards the serverless side of things, which is, things like AWS Lambda, things like AWS ECS, Kubernetes as an example. So in that, you don't have to create a server at all. So there's no such thing that, you need to create an EC2 instance, or you need to set up a CPU and memory for it. Nothing like that. You just basically create and again, AWS Lambda is not exactly a replica of what an EC2 instance does. It's more ECS. But with Lambda, all you care about is you just create your code, you just run that AWS Lambda, and you only pay for the run of it. And you don't have to worry about the patching. You don't have to worry about, how do you, as an example, like how do you um, you know, like sort of having an AMI building, like a pipeline or something like a CI/CD pipelines to build the AMIs. Because even for the AMIs, some companies like to package all the software in that AMI. As an example, if your application needs an Apache server, so you're not going to create an EC2 instance and then install an Apache server. Instead, what you'll do is that you'll build a pipeline, you will install the Apache server in it, and then you'll build the AMI out of it. So this way, once you build an EC2 instance from that AMI, it will already have an Apache server built into it. So that is what an AMI is. Whereas with Lambda and all that, you don't have to worry about
Sorry,
any of
Aditya,
those things.
can you simplify AMI? I sort of vaguely understood what is AMI, but can you just
Mhm.
repeat what you said about AMI?
No worries. I'll do one thing. I'll just show that in the in the UI,
Sure.
and then I think it'll make more sense. So what an AMI is all about is basically, if I go to EC2 console, right? And now someone tells me that, build me a WordPress website or something on an EC2 instance. Now what do I need to do is that I just go to the instances, I just do launch instances, and here is where you would see an AMI. So it'll ask you which OS do you need, right? So you'll see over here Amazon Linux, Mac OS, Ubuntu, whichever one you need. And the actual resource that it uses to build that image is an AMI, is an Amazon machine image. It's basically all the OS built into that resource and packaged up to basically give you the ability to just run the EC2 instance straight away using that AMI, and that is what your OS is. It's nothing but your OS,
Oh,
Microsoft, Red Hat, or whatever you need.
so is it like a snapshot of the OS?
You can treat it as that, yes, 100%. So it is kind of a snapshot of the OS, yes. And another beauty of the AMI is that, say for an example, tomorrow I go and create an EC2 instance, and I say that I'll launch like a very small web server, and I'll install whatever I need in it. I can actually create a snapshot of that EC2 instance and export that into an AMI, so that future EC2
Oh,
instances can then use that AMI with my prepackaged code, so I don't have to worry about installing things again and again in my server.
oh, so then we can use it to work remotely from anywhere, anytime, and from any device.
Yeah, 100%. So, I mean, look, I mean, normally with servers, you can work from anywhere, anywhere. But the whole idea is that it solves your problem of, packaging things again and again, right? Now, if there's only one server, that's easy, right? Now, when I talk about 100 servers, that means that I need to say, for example, I create one server, I need to install Apache, I need to install, a couple of Linux packages like JQ and all these other different packages I need to install. I need to do that for 100 different servers, right? So instead, what the AMI would do for me is that I create one server, I put all the software that I need from it, then I export that into an AMI or create a snapshot of it, and that is my new custom AMI that I created. And that custom AMI is what I use to create 99 other servers. So that way, those 99 other servers will all have these packages already.
Oh,
Does
Yeah,
that make sense?
thanks, Aditya. Kishan, just
No worries.
post the questions on the chat. Okay, we'll take it up a little later. Let's go through. Yeah.
Cool. Perfect. And then what you do with the EC2, and again, since we are here anyway, so I'll just show you a couple of things over here, is that once you basically select the OS you need, that's the AMI that AWS automatically assigns to you. Now with these AMIs, most of the time it is AWS published AMI. So that means AWS has put security patches on it, has ensured that all your softwares or things that are already packaged in it are all up to date. So AWS publishes those. So you can see that you just have to pick up whichever you need. You can even like go over here and then select some of the other ones, because AWS has got some of the other AMIs with SQL Server already installed as well. So you can see that you can basically do anything that you want. And then based on that, you get an AMI ID. So you can see that this is the AMI ID you get. And that is what you know helps you create that EC2 instance. That is what has your OS inbuilt into it. It is exactly like how someone just mentioned snapshot. So it's kind of a snapshot, but in the background AWS does that thing. So from our side of point of view, or our side of things, it's basically just an image which basically has the OS built into it. All right. The other important thing is the instance type. So basically, you select the instance type over here. You basically ensure that if you think that your workload is quite big or massive or small, whatever, you select 2 vCPUs or 4 GB of memory is what you need. And then you just can go any higher that you need or any lower that you want. So you can just basically take your pick from here and then select your instance type. And then this is the key pair. So key pair is basically creating your SSH key. So once you create an EC2 Linux server, you need to be able to SSH into that server, or go into that server to install those packages, right? So then you would create a EC2 key pair over here. And then this is where your VPC thing comes in. So you also need to ensure that you create it in a network, right? So inside a VPC network space, as an example, 10.60.0/16, you would get a subnet, and in that subnet is where you would create this EC2 instance. So this is basically your networking layer, and then you would then just create that EC2 instance within that network. And this is where you would then decide what is the storage that you need on that EC2 instance, whether it's 50 gigabytes, 100 gigabytes, or whatever. And then you would just launch the instance straight away. There are obviously all the other options in there which are way more advanced, but this is like the basics of what an EC2 instance is and how do you create it. So what I'll do quickly is I will create one small EC2 instance anyway, and then by the time we are through with the rest of the slide or presentation, this would already get created, and I'll show you guys how to access it and do other things. So let me just create the Amazon Linux, so that's fine, and I'll just create a new key pair. Okay, just name it anything that you want, create that key pair. So you would see that it downloaded that private key for it, and I'll show you how to access that later. And then everything else looks okay to me. Then I just launch the instance. All right. So if I go to the instance, it'll take some time for it to be able to, run properly. So we'll wait for this to come online, and then we'll proceed with the other stuff till then. All right, perfect. And moving on to the storage bit. Now, in AWS, you get a couple of options with the AWS storage. Now, one of those is AWS S3 or Amazon S3. Now, some of you might have heard quite a lot about this. So this is basically, to do with everything to do with the images or files or anything that you can think of. All the applications which are on AWS, almost 99% of them have their storage with AWS S3. So what this is all about is, say for an example, you are hosting, as an example, you're hosting Amazon.com, right? Just a rough example. So you are hosting Amazon.com on EC2 instances. Now, you would have noticed in that Amazon.com, once you go, you would be able to see like all these product images in there, right? So once you go to a product, you would be able to just scroll across those images and then see different images of those products and all these things. Now, all these images, you don't expect all these images to be on the server itself. The reason why I say that is because if you have a website as big as Amazon.com, you would have thousands of servers for that, or thousands of EC2 instances for that. For you to be able to serve that image and that image to be present on that EC2, you'd have to have that image on every single server that's out there, right? So that means thousand copies or thousands of those servers will have a copy of that image, and that is obviously not feasible, because that thousand can scale up to, say, tomorrow 10,000 instances. So you can't copy that image onto every single server that's out there. What you would do instead is that you would put it in a central storage. You would put all those image files in a central storage like Amazon S3. And then what your website would do is that whenever it needs that image for that particular product, it'll fetch that image from the AWS S3 and straight away present it to the client. So this way, you'll have a central storage, you'll put all your images into it. Your website, when it needs to present that to the server, you click on something, you click on a product, you click on a link. Once it goes to that link, from the back end, it will automatically make a call to that Amazon S3, grab that image, and then display it to the user straight away. So this way, thousands of servers are now using just one single repository to get all their images. So this makes that process very, very easy. And you can imagine that almost 99% of the workloads that are on AWS are using Amazon S3. All right. Then the next bit is the EFS. Can you all see my screen? I think I lost one of my screens. Can you all see my screen?
Yeah, we can see a screen with S3,
Perfect.
EFS, and Glacier.
Yes, perfect. Thank you. All right. Then the second service is called Amazon EFS. Now, what this is about is that basically, as an example, um, I was giving you an example of Amazon.com, in which you would have these thousands of servers with all these images. Now, say for an example, you and I think I showed you guys this, is that when you went on the instances tab, you saw an option of storage over there. So I can set 50 gigabytes or 60 gigabytes or whatever. Now, say for an example, you have a use case in which somebody changes something. Now, every time you don't need S3 for everything. So say for an example, somebody changes some file on something, and you want all those 1,000 EC2 instances to get that particular file. Even if it gets changed on one of the servers, all the other servers should get that change. So this way, all the servers are across, the changes in that single file. So that means the traditional storage that you give on Amazon is called as EBS, which is I think it's called Elastic Block Storage. So that EBS volume is per EC2 instance. So that means the storage that I set over there for that, and this is what I can even show you from the UI itself. So if you see, this is my EC2 instance over here. So if I click on that, if I go to the storage bit, you would see that it created a volume for me. So this is nothing but your EBS volume. So this gets assigned to every single EC2 instance that's out there. So I create another EC2 instance that will get its own EBS volume. So this is like your local storage for that particular EC2 instance, right? Now, if you have a use case in which you need this storage to be shared across everything or every single server that's out there, you would then create something called as an EFS. So what this EFS is it's nothing but your network file storage, right? So what it does is that over the network, it will attach on a specific folder inside your EC2 instance, and then it'll be exactly like that on every single instance that's out there. So this way, you say, for example, in the 1,000 servers, you go to server number 998, and you try to change one file in that mount point or wherever, or that folder on which you would have mounted that EFS volume. If you go inside that and you change any of the files, all the 1,000 servers are going to get that change. So this way, you make sure that you don't have like singular storage for different EC2 instances. You change one of the files in any of the servers, it carries that change across to every single server that's out there. But it is 3 times the cost of EBS as well. So you also need to ensure that, again, cost optimization is one of the pillars on the way that you design your web application. So you need to ensure that if you don't need EFS, you shouldn't use it. It's only for specific use cases. And then Amazon Glacier. Now, I'm not going to go deep into Amazon Glacier. So again, this is for the organizations that have got lots of on-premise data. So as an example, if your organization is moving away from on-premise into the cloud, and they have petabytes worth of data, thousands and thousands of terabytes and petabytes of data, and they need to move all of that into cloud, then you order something called as Amazon Glacier. So it's exactly like a big truck that they bring in with all the servers. they get all your data out, and then they ship it out to the Amazon data center, and then put all of that data wherever you need. So it'll put it into an S3 or S3 bucket or somewhere, and then it'll store all your data over there. So that is what that Amazon Glacier is. Again, it's a very advanced use case, and most of the people don't even care about it, because startups would directly start using AWS, and they wouldn't have all of that extra baggage of all that data. It's only for the big organizations that are that have just started moving into the cloud, and they need a faster way to transfer all their data, and they can't do it over the internet. All right, perfect. I'm going to pause for some questions. Are there any questions till now?
I think there was one question somebody asked. Can we use EC2 to work remotely from anywhere, anytime, from any device?
Yeah, 100%. I mean, look, EC2 instance is just like your server, right? So, but what I want to understand, what do you mean by working remotely? Like, is your question about, can you access AWS console remotely, or like, what was the actual question?
I think we'll let it pass. You continue, Aditya. Mm-hmm.
Okay. All right, perfect. Uh, cool. So the next one is a demo for hosting a static website on S3. Now, as an example, say for an example, you tomorrow get employed by a company, and the company says that I've got a web page. It's a very simple website in which there is no dynamic stuff going on, as in it's not reaching out to another website to try to see the weather information or anything like that. It's basically static content. That means that I've got a food website. It just displays a bunch of different dishes, and it's got some information on where to reach out to us, and what's the address for our restaurant, as an example. It's a very simple static website. So the thing is that for these kind of very basic scenarios, you don't need EC2 instances. AWS has provided you a service in S3 itself, which is called enabling the static website hosting. So that means you can actually put all your content into the S3 bucket itself, and you can enable static website hosting on the S3, and S3 itself will act as a server, right? So
Uh,
this way,
Sorry,
you don't have
Aditya.
to worry about creating an EC2 instance.
So Aditya, what you're saying is, if let's say if we have 20 people in this room, if all of them want to create their resume and put it up on some public IP,
Mhm.
they can take an S3 instance and whatever with the knowledge of HTML coding, they can build it and make it live immediately.
100%. 100%. And
Okay.
that is what I'm going to demo for as well.
Yeah.
Yep. 100%. So yeah, as I said, again, an S3 bucket. So you can just create, an S3 bucket, and basically put your resume on that, and then you can just basically deliver it to the world, and everyone can see it. So it's as easy as that. So you don't have to. So you can imagine, like, if you are a newbie into it, you don't have to worry about creating an EC2 instance and then installing Apache and all that. You don't have to care about any of those things. So because those are, again, a little bit advanced topics, and people need to exactly know what they're doing. So this way, you just put all your index.html and all your images and everything in the S3 bucket, enable that static website hosting, and then just send it out to the world. All right, perfect. I'm going to show you how to do it. So let me just show you that. All right, so I'm going to go to S3 over here, and let me just go to Route 53 and see if the domain that I have. Just give me one sec. All right, perfect. Okay, so I'll just create a bucket. Say, for an example, I want my website's name to be AdityaAWS.click, right? That's,
Sorry,
it can be
can you
anything.
rename that thing? Can you call it SMVATM for this demo? Our college name is
Okay,
SMVATM.
so SM, ATM,
SMVVITM.
VITM.
Yeah,
All right.
that's it.
Okay. So if you want to call it that, so dot click, anything that you need. So basically, this is the domain that you would go to, once. So you need to ensure that whatever domain you want to set on the browser, that's the name of the bucket that you give. So you need to ensure you do that. All right. So smvitm.click, and I will just basically, so a couple of things that you need. So now, because you need the whole public to be able to access it, you need to turn off the public access, right? So you need to turn off the block public access. So this way, anyone in the world can can access it. So I'll remove that. I acknowledge, and then I'll disable some of the other stuff. Okay, and then create bucket. All right. So if
But
I now go
for
inside that,
Aditya, but for hosting a website, you need a web server, right? So does S3 come with a
yeah,
web server in this case?
100%. And I'm going to explain that 100%. So it comes with everything. So I'll just show that. So first, what I'll do is I'll have to set up a couple of things first. So I have an index.html page. So I've got this this website that I built back in the days, and again, it's a very basic food website. So I'll just have to copy that across into the other bucket over here. So let me just download the index.html from here. Okay, and then I'm gonna put it over here, upload. Okay, let me just rename that first. Just give me one sec. It needs to be index.html. All right, so rename that, upload that file, all done. Now it won't have all the images and stuff because all the images were in those other folders, the resources and all that. But this will give you an idea of how to serve that index.html. So now if I go into that bucket, all I have to do is just go into the properties, and over here I have to find something called as enable static website hosting. So I edit this, enable. Right. Then in here, I'd have to put a couple of things. So just give me one sec. So in that, it'll ask you basically, what's the index document, which is my index.html, which is my root document. That's the one that I wanted to pick. And then once I go to the, and if you've got the error document as well, so say for an example you want to display a certain certain web page when there's an error or something, you can even put that in over here. And then you got to apply some redirection rules. So say for an example, if you've got any like redirection based on specific paths, say for an example slash content needs to go somewhere else, and again, this is all advanced stuff, so you can set up those redirection rules. So it's exactly all the things that your web server would give you, and like your Apache or whatever, so but on a very basic level. So then I just save those changes. All right, and then after that I think I might have to add another bucket policy over here for everyone to be able to access it. So just give me one sec while I just copy the bucket policy that I need. All right, and that's the name of the bucket. And again, this will make sense once you all try this yourself. So this basically tells that you're allowed to do S3 get. Everyone principal is star, so everyone is allowed to do S3 get object. That means everyone is allowed to be able to access contents of this particular bucket. And then I save those changes. All right. And then when I go to my properties, my website should already be live on this particular URL. So if I go to that URL, there you go. That's my website. So you see how easy is that?
Wow, that's nice.
That's it.
So good. This was the restaurant that you opened in Australia for a while, right?
Yeah. So
Very
well,
nice.
back in the days, I was trying a couple of things at that time. So I just built one website, myself, and at that time I had hosted it as well. And then the code has been with me since. So you
Nice.
can see, like in just a couple of minutes, you're basically live. You have
Mm.
a static website, you have a restaurant, or any restaurant comes to you and says that I want to, create a website for me. You can see how easy it is to host it for
So
yourself. You don't
somewhere in
even
the
have to
middle,
know
in the
most of
beginning
the
of the
database stuff.
session, somewhere in the beginning of the session, you talked about something called Route 53 or something, right? What was that?
Yes.
Mm.
So what Route 53 is, it's a domain registrar for AWS. So as an example, what happens is that, say for an example, tomorrow people come up with their own domain name, like you know aditya.com as an example, right? Now, usually what used to happen is that you used to have these domain registrars out available in the internet, like, I think it's called GoDaddy or something, and there's a couple of other ones that you can go up to. Just like that, AWS has its own domain registrar, which is Route 53. So you can actually go to registered domains, and I'll just show you in the Route 53 console. And then you can just register your own domain over here. So I can just do, aditya.com or something to see if it's available. And then I can just register myself a domain. And once I do that, the Route 53, what it allows you to do is also set up a hosted zone. So what this means is that now I just don't want a domain. I need to point my website to a particular domain. Like, as an example, the website that we just created, smvitm.click, if I own that domain, so that means if I now register myself into that domain, I can then create a hosted zone, and in that I can create records, DNS records, to then say that, say for an example, smvitm.click should go to that particular S3 bucket where my website is hosted, or go to that EC2 instance. Now tomorrow, if I create an EC2 instance and I put my food website in there, I can, I've got an IP associated with that instance. All I have to do over here is create a DNS record to say that, www.aditya.com should point to 3.39.59.48. That is the IP of that particular EC2 instance. And anyone that tries to go to that aditya.com will be able to, go to that particular EC2 instance, and then, be able to see that website. So that's the whole idea of, what
Yeah.
Route
So
53
Aditya,
is all
just
about.
to clear my doubts, what you did in the first instance was hosting, and what you are trying
Mhm.
to tell now is how to map a domain to the hosted server, right?
100%. 100%.
Okay. Right.
Yep.
Thanks. Go
So
ahead.
this is the mapping the
Yeah.
domain. Yep.
Aditya, since
Cool.
we may not have enough time, one thing definitely the team wants to know is about Lambda, yeah, AWS Lambda. Okay,
Right.
that's something
All right.
serverless
No
you
worries.
said. That's a very gray area for us. So try to focus on
Sure.
that, please. Mhm.
No worries. I'll do one thing. I'll just leave the other part of the slide, and I'll just show you the demo of Lambda, AWS Lambda, and see how show you how to use it. All right. No worries. Let me just turn off the site hosting. Otherwise, I'll get billed quite a lot. So let me just disable it. Okay. All right. So let me just jump into Lambda. All right. Now, what this AWS Lambda is all about is, say, for an example, you've got a use case in which, I'll give you a very, very basic example. You are building an application which involves an EC2 instance, which involves a database, right? And then some sort of a storage layer like S3 or whatever to put your images in there. Now, what happens is, in the real setting and in the real world, people don't do these things directly, by clicking on things and then creating these things. So you use something, like a software like Terraform or CloudFormation, which basically, creates your infrastructure as code. So you can just basically deploy to whatever you need. So as part of that, as an example, you are building the EC2 instance plus the database, which is in RDS, AWS RDS. That's another service in AWS. So you build these two things. Now, when you deploy this application, which has that server plus the database, you need to create inside the database from the AWS side of things. It doesn't give you an option to create database users inside that particular database. That you'd have to do manually. So that means that you'd have to go inside. So once you build the application, you'd have to go inside the database. You'd have to, say, for example, it's a Postgres database or SQL Server or whatever. You'd have to go in, run the SQL queries to be able to create those DB users, and then set the permissions on those users and all that. And that is what your application is then going to use to connect to that database to grab all the rows and records or whatever it needs. So that is how it works in the real sense. But as an example, what I always keep saying is automation is the name of the game going forward. You don't want to create that website plus the database and then go manually inside the database and then create all those DB users. You need some sort of an automated way to be able to do that. That is where AWS Lambda comes in. Now, what AWS Lambda is all about, and hopefully in these functions, I would have some code. So if I show you over here, let's wait for it to open up. Oh, I think it's in a different language, Golang. All right, I'm not going to talk about that. Yeah, this one is Python. So if I go into Python and if I show you this one, yes. So what AWS Lambda does for you is that it allows you to use programming language, any of the backend programming languages, to then be able to to then create the DB users as an example. So that means you would be able to. So if any of you know Python, so, or Golang or .NET or Java, any of the backend languages, so you can use those languages to then connect to the Postgres server or the RDS server, go inside that server and then create those DB users. So this way, when that pipeline runs, when that CI/CD pipeline runs, which basically builds your server and your database, it automatically then deploys the Lambda function as well and runs the Lambda function, which then connects to the database, automatically creates all those DB users using the Python code, and then finishes it up. So by the end of it, when the pipeline finishes or the pipeline runs successfully, you'd have everything. So you'd have your DB users, you'd have your database, you'd have all of that. So you don't have to do any of the manual tasks. And the beauty about Lambda is that you only pay for what you run. So say, for example, your Lambda ran for 3 seconds. That is the 3 seconds that you pay for. You don't pay for just creating a Lambda function. It's just there. It's not going to cost you anything. You only pay for how much you use of it. Cool. Any
Yeah.
questions on this one?
No, thanks. So I mean, what I remember in the earlier days, if you want to use AWS Lambda, you need to know JavaScript. But here now you told me there are other options like Python, Java, Golang,
Yep,
etc. Is that right?
that's right.
Mm.
Yep. So once I create the function, you'll be able to see that there's an option which says runtime. So you can select any runtime that you need. So you can select .NET 10, Java, Node, Python, Ruby, Amazon Linux as well. Like if you need any custom runtimes, like C++ runtimes or something, you just select this and then package your code up with that.
Okay, I'll give you an example. Just tell me whether AWS Lambda is the right thing. I need
Hmm.
to send a happy birthday message to every of my student at 6 a.m. in the morning. Is there
Hmm.
is it possible for me to create a AWS Lambda function, deploy it such that it checks at 6 a.m. who are the people whose birthday falls today, and I want to send them a happy birthday message. How would you do that using AWS
100%.
Lambda? Hmm.
That is exactly the use case for Lambda. So the way that you do that is not directly by using Lambda. There's another service called as Amazon Events Bridge. So what that does, it works on basis of a schedule. So basically, you set a schedule on that, saying that at 6 a.m. trigger this AWS Events Bridge, and that Events Bridge is going to trigger this Lambda function. And this Lambda function says, say for example, you want to send an email to all the students that are out there. So there is another service in AWS called SES, which is Simple Email Service, which is you can set up your own email server in there. So once the Amazon Events Bridge triggers at 6 a.m., it's going to send a notification to AWS Lambda. The AWS Lambda is going to run the code, have the message, happy birthday, whatever that student name is, and then it's going to use the SMTP server to send an email to that student's Gmail. And that will be your flow, or that will be your use case. So that is how a use case gets determined. You use
Uh,
different services, you package them all
Yeah,
together, and then you
just
do
to
that.
clarify, I think what you said was, suppose in Python I create function one, function two, those functions can be independently deployed on AWS Lambda. Am I right?
Yep,
Okay. But
100%.
the use case which I said was it should do a like a scheduler kind of thing. For the scheduler, Amazon has another product called Amazon Events Bridge. Once the
Event switch.
scheduler
Yep,
is wakes up, then it will call the function which is written in AWS Lambda or deployed in AWS Lambda. So there are two Amazon
yep,
services coming to picture: the Amazon Events Bridge for
100%.
waking up at the right time, and the Amazon AWS Lambda for executing the function. Is that right? Mm.
That's right. Because AWS Lambda itself doesn't have this scheduling option out of the box because it's a service to just have your code and it just runs the code. For it to be able to run at a particular time, there's another service which then triggers this Lambda function. And again, once you go into the depth of it, say for an example, you've got a particular code, but then you need to ensure that at 6 a.m. Say for example, you set the schedule at 6 a.m., 7 a.m., and 8 a.m. Right? You need to send happy birthday at three different timings, but you also want to ensure that you send those timings back to the user as well. So happy birthday, say Aditya at 8 a.m. Happy birthday Aditya at 7 a.m. You want to set that information as well. So this Lambda will then accept a payload as well. So the way the Lambda works is that it accepts a JSON payload to say that, say for an example, you've got a bunch of code inside which says happy birthday something. You will variabilize that part which has the time, and then you will expect the time from the payload. So when the AWS Events Bridge triggers at 6 a.m., it's going to invoke the Lambda function and pass that payload of 6 a.m. into the Lambda function. Once it invokes it, the Lambda function gets that payload of that time, and then through the SES sends an email to that student, and has that 6 a.m. in the line. And at 7 a.m., that's the same thing happens, and then 8 a.m. again,
Right, right.
same thing.
Yeah, I
So
think
that's
a
how that's
good
how the AWS
use
works.
case for this is the Reserve Bank of India publishes the dollar rupee rate. Maybe some
Mhm.
banks want it at 6 a.m. because they are based in Singapore. Somebody maybe wants it at 9 a.m. because it opens at. So the dollar rate at 6 a.m. was so and so. The dollar rate at 9 a.m. was so and so. So that may be a very
Yep.
good use case for this. Okay. Mhm.
100%. And this is what I was showing from auth. So if I go into this Lambda function over here, so you see that as an example, if I test this Lambda function, so you would see that it also expects a payload, like a JSON payload. So in that, I mean, this is obviously a test scenario. This actual payload will come from Events Bridge in that case, the timings and all that. But I can even pass like Aditya engineer, like that. So I can even pass that. So if my inside code expects a variable at certain point, I could pass those values from here, and then my code would say that look for the key Aditya and take its value as engineer, and then send that value whatever wherever you need.
Okay. Aditya, can you tell us something about Docker and Kubernetes? It's a black box to us. We're not understood that concept properly. Mhm.
Sure. So again, Docker and Kubernetes are very, very big concepts. And look, Kubernetes is the way of the world, especially for the big organizations going forward. Now, what first I'll just talk about the Docker part of it. So Docker is basically your previously when you used to do virtualization for the VMs and stuff. So it used to be a full-fledged VM in which it'll be its own operating system and all these other things, and it's quite heavy on the whole system. So as an example, if you all remember VirtualBox, we used to have these virtual boxes, and then we used to create these VMs, and it used to use quite a lot of the CPU or the memory capacity for your particular laptop. So with Docker, what you do is that you only it's an OS level layer virtualization. In that, what it does is that you create all these small containers and you package your code in it, and that is all it cares about. So say for an example, if I need my application as Amazon.com, I package that up in a small Docker container with the image as CentOS as an example, or Debian, whichever OS I want to use. I package all of my code in that, and I just worry about that part, and it just hosts my application and runs my application. It doesn't care about anything else. It's not heavy on the system. It's not virtualized on the system. It's OS level virtualization rather than hardware level virtualization. So this way, you just create these small Docker containers for whichever application you need, and on one single system, I can basically have 1,000 different Docker containers, one with Debian, one with CentOS, another one with RHEL, the Red Hat or whatever. So you can have all these different OSs in just one single laptop.
So,
Does that
so
make
how?
sense?
Yeah, but to make a Docker, do I have to go to some vendor or what's the like?
No. So you can. So if you are just using like a free version of Docker, you can just do it directly from your system. So I'll just show you that. Um, so I've got Docker on my system. So all you have to do is just install Docker Desktop on your laptop, like this, exactly like this. And if I do Docker PS, right? So that's one of my Docker containers running at the moment. Now, as an example, if I need to run Hello World, just giving an example, I can just do Docker run minus IT. I can serve it on port um, 80 and hello. So with Docker, I need to see which image that I'm trying to use. So let me just first find the image. Hello world Docker. So that's the hello world image. And what I can do is that if I find the run command for this one, just the hello world. All right. I think that should be it. So you can see that I am able to run the hello world straight away. And there you go, hello from Docker, and that's the image that displays. So basically, what you saw from here is that somebody somewhere has put all these images up in Docker Hub, whether it's Ubuntu, Hello World, Linux, Windows, or whatever, and I can just run my Docker container, which I can serve my website, and I can even host these websites on any of the serverless platforms going forward. And that is what that Kubernetes is that once you have, like, say for an example, thousands of Docker containers in there, and you need to orchestrate those, and you need to ensure that they scale properly, they handle the load properly, they've got a load balancer in front. That is where the Kubernetes comes in, which sort of helps in the orchestration of all those Docker containers.
So Aditya, I think we can park Kubernetes for now, but just all of us have laptops. So
Hmm.
first thing to run Docker is we need to download something called Docker Desktop. Is it?
Yep. So just online, once you go and just type install Docker on if you've got Windows or whatever, so
Hmm.
it'll give you all the information on how do you do it.
Okay, after
It's
I
pretty
download the
straightforward.
Docker Desktop, it's like a container kept inside my laptop for doing certain
Mhm.
things. So now different
100%.
developers have creaed different Docker images on various
Hmm.
interesting things. So I can go to hub.docker.com and I can pull whatever image I want, and that
That's
gets
right.
streamed to my Docker container. Is it?
Exactly right. So this way, you don't have to, build things from scratch or anything. So if I go to my Docker Hub, you'd see that, say for an example, I'll give you an example that someone has built, as an example, the Apache thing. Someone has already, put the Apache server and all these different packages in a Docker image and publish that on Docker Hub. You don't have to build it yourself. You can just download that image and then start working on it.
Okay, let's say we have one of our students here, maybe Pawan or something. He has built a Hello
Mhm.
World. Is he also
Mhm.
allowed to, put it in the Docker Hub?
Yes, he
I
is.
mean,
He
there's
just has
no
to create
restriction
his
or
account.
something.
There's no restriction
Okay.
unless he's trying to use it commercially. So, say for an example, he has a company or something, and he needs, lots of people in his company are trying to use Docker. Then Docker will reach out to you saying that you need a business license now. As long as it's personal use, Docker doesn't care.
So yeah, this is meant for our students, Aditya. See, I think what we do is a lot of us go for hackathons to
Hmm.
different colleges. So what we can do is
Yep.
we can all create one small toolbox which has so many simple utilities like encryption, encoding, and a lot of prime number calculation and all those things. We can put all of that in a toolbox, and we can create a Docker image and deploy it in hub.docker.com. So when we go to
Hmm.
hackathon, we just download that from the hub, and our productivity will increase tenfold.
That's it. That's it. That is exactly correct. You can
Yeah.
100% do that. And you just don't have the option for Docker Hub. You also have it in AWS. AWS has its own image registry called ECR, which is Elastic Container Registry. So Docker Hub is one option. Say, for an example, you don't want to go to Docker Hub because you think that you've got lots of images, and Docker might have reached out to you saying that you need to start paying for it. You can just go to let me just open up AWS version of it. So AWS has got its own version of Docker Hub. So ECR. So if I go to ECR, Elastic Container Registry, so it's exactly like a Docker Hub. So as I said, AWS is basically an amalgamation of everything that you can think. All these different services all coincide on AWS. So it's got its own version. So if I go to repository, all I have to do is just create a repository, build your image in a Docker container on your local, and then you just push it over here.
Okay. Okay, there are two questions I'll read out. What is the best way to configure AWS budgets and limit our exposure to billing? Mm.
All right. So if you go into the account section in your AWS console, I'll just show you from here, and you go to budgets, right? So you would see that I've already set up a budget over here. So you can see that I've set up a budget for $10 because obviously I don't want to pay too much. And all you have to do is over here, go create a budget. Decide on whether it's a monthly budget or notifies you when your spending exceeds $0.01 or whatever, and then you set the exact sort of money on which you want the budget on. So say for an example, I need to set a monthly cost budget of $100. If I create EC2 instances, S3s, and all these other things in there, and I forgot to delete them, this budget is going to see the projection of that bill. Say for example, it sees that you've created an EC2 instance with 2 vCPUs and 8 gigs of memory. It knows, or it projects, that it's going to go beyond that $100 of budget that you would have set. So it'll tell you right away in advance itself that your budget is exceeding, and then it's going to send you an email so you get alerted straight away. So please make sure, if you are new to AWS, please make sure to set this up, and then you set up the email recipients. So you set up your email address or whatever, and it's going to send you an email saying that your budget is going to go overboard. Please make sure you delete the resources. So this way you're assured that you won't lose too much money.
Okay, let me throw open the room for more questions. Ravi Kumar, Rahul, Sakshi, Prashant, Anish, Naina, Vakas, Roshni, Pritesh, Pavan. I mean, Aditya wants to hear your voices. Please, please ask questions. Yeah, please. At least one question. Aditya, you can
Hello,
take
sir.
this. Yeah, please. Yeah.
How Amazon is more yeah, advantage than other cloud like Google or other?
I wouldn't say, look, at the end of the day, what I say is that, look, I've used basically, almost every, big cloud provider out there: AWS, Azure, Oracle Cloud. Um, the good thing with AWS is that they're very good with serverless side of things. So if you see any of the cloud providers, they've all got the competing services which are doing exactly the same thing, but just with different names. So that means that if you're on AWS, you have AWS Lambda. If you are on Azure, which is a Microsoft owned, you have Azure Functions. If you are on Google, I think over there as well, it's called Google Functions, and then same thing is with the Oracle Cloud. The beauty of AWS is that the serverless part of it, the AWS Lambda, the ECS, they're really really good at it, and it's very cheap as well as compared to Microsoft and all these other cloud providers. So but the other side of things, the server side and all that, it's almost the same. But yeah, I think AWS really shines in the speed on which you can deploy things on, because AWS APIs are very very quick. So I think when we talk about the agility of the service, AWS actually is in the lead. But where Microsoft comes in the lead is because Microsoft already has these enterprise agreements with most of the customers already for Microsoft Word 365 or whatever, and they just say that we're gonna, lessen your bill for the Microsoft Azure by some certain amount of dollars, and you just go onto Microsoft Azure. So hence why bigger organizations choose Microsoft Azure versus AWS, is because they already have these enterprise agreements with them.
Yeah, thanks. Ravi Kumar, can you read out your question?
My question is that what types of cloud projects make a strong portfolio for cloud engineers roles?
Yep. So look, at the end of the day, before going into the project side of things, you need to first understand all these services. So obviously I didn't go through the whole slide, but then, in my slides somewhere, if I show you, if I go all the way forward, um, so I've got a couple of, cloud certifications that obviously you guys can go into, but the main idea is that you start from the Solutions Architect Associate course. So I've given the links of the courses as well. So, any of you want to start learning it, I always say that, if you want to learn something, you got to go get it. It's not something that someone comes in. Look, it's a privilege for, teachers to come teach us things. But I always say, if you need to learn something, you got to do it yourself. You got to put in the extra efforts yourself. So from Udemy, I think it's probably, if you haven't signed up to it, it's probably only 500 rupees or 100 rupees. I just can't remember. So these courses are pretty cheap as well. So you can just sign up to these courses and then start learning, AWS Solutions Architect Associate. So if you are new to AWS, I would recommend this as a starting place to understand AWS and then prepare for those certifications.
Sure.
Yeah, thanks.
Thank you.
Actually, Aditya, I have one very important statement to make, but I will reserve
Mhm.
it after I request Rahul to thank you for the session. Rahul? Mm,
Sure, sir. On behalf of SMVITM, I would like to thank Mr. AdityaKachroo for delivering such inspiring online session. Sir, we are motivated and have gained a valuable knowledge from your talk. We would like to happy to invite you to our college when you visit India, sir.
Definitely. Thanks for that.
Thank you, sir, for your session.
yeah, Aditya, I have some very important statement to make. And Soumya, I hope you are also listening. Okay. Mm, yeah, Soumya, we have not heard your voice. Can you say hello? Uh,
Yeah, hello.
yeah.
Hello, everyone.
Yeah, just as a background, I attended Soumya and Aditya's marriage in Jammu about a year back, or 2 years, 3 years back, is it? Yeah. Yeah.
Yeah, almost 3 years now. Yeah.
Yeah, Soumya is the daughter of my classmate, childhood friend. His name is Ravi, and Soumya is Ravi's daughter, and Aditya has been a great partner for Soumya. I want to propose something very important. Okay, I think all the people who attended today's session are very excited, but they are not comfortable with the billing process of Amazon. Okay, it might give alert, it might give a budget, but it can spoil a family, it can destroy a family. Okay, we are in the most rural part of India with just hand to mouth existence of all the people, and you will not believe the kind of financial jugglery which every family does to even catch a bus and pay 10 rupees to come to the college. It's not easy. Okay, jobs are difficult to find out, parents are struggling to get 2 square meals a day. Okay, it is very different world. Okay, so what I am proposing to Aditya, I don't know now or something, I think Aditya and Soumya have enough capability to create a poor man's Amazon in India. I think somebody like Aditya should build a simple equivalent of what Amazon has done, okay, and provide it to all the engineering students in India. Okay, that single act of yours, Aditya, can transform the country like anything. Just transform the country. I think Soumya can understand where I'm coming from because she knows my line of thinking. I have seen Aditya. Aditya is one of the most competent persons in this, much more competent than anybody in the US or anybody. And Soumya has been such a great emotional support for him. And I can tell you one thing, all my students here will support you. Okay. So today, from today, I am offering 4 of my students as interns to you for the next 2 years. Okay. You can pick and choose. I will give you the resumes of 20 people. You pick 4 interns from here, and they will be at your beck and call for any software development or any kind of a technical support. I promise 4 students will be available to you. You don't need to pay them anything. Okay. But whenever they don't have exams, when they are free, you give them work and they will do it. The work can be either development or DevOps. But do plan 1 year from now, 2 years from now, 3 years from now, do plan to create a cloud infrastructure for our country where we set the rules, we set the budget. See, the way I need the budgeting is something like this. I go to a shop, I pay 500 rupees, and I get 500 credits, I don't mind putting that coupon number in Amazon. So when the credits gets over, it should stop the service. I should not have the fear that money will be drawn from my debit card and from my bank account and make me poor. That fear is simply not acceptable. Okay, so none of the people here are using Amazon or Google or Azure. They will not use also. Whatever you do, they will not use unless somebody like you comes and creates a simple, simple cloud infrastructure for us to do simple things. Our requirements are not Kubernetes, etc. Our requirements are, I want to see my exam result, I want to say birthday greetings. Very, very simple requirement. Okay, and also what I need is, I don't want somebody to say, okay, here is Amazon, learn everything about Amazon. No, my focus should be, how do I create an application and how do I deploy it. I mean, the learning process should start from a need. I don't want to say that here is a building, go and explore every corner of this building. That is not the way one learns. There's no motivation for somebody like Pawan. There is no motivation at all. But Pawan comes from a rural district in Karnataka called Bagalkot. His father is having a shop. He wants to create a website for his shop. Okay, what if you tell him how to create a website for his shop? He will be excited to learn. He will not be excited to go to Udemy and learn Amazon, because there is no motivation for him at all. So you have to change the rules of the game. Okay, and probably you will not be able to appreciate that unless you come and visit our college, see the countryside, and experience what is happening here. So see, you can see, I have seen both worlds. I have lived in the most modern economies. I visited 25 countries. I have had fat salaries. I have had extremely luxurious life. But I am in the most rural area, teaching students who are very, very, what you call, excited to learn, but who don't necessarily know how to go about, and they need mentors like you, they need role models. So I think, I'm edging you or nudging you to do something back for our country whenever you have the time. Okay, that's it. I don't expect any answer, but Soumya and Aditya, do visit our college, do come to Udupi, stay for a day, and our college will be free to, I mean, will be most happy to host you, and you can conduct an entire day's hands-on session that will definitely create 10 more entrepreneurs from this group. Okay, I guarantee that. Okay.
Thank you
Definitely.
for that. That was very beautifully put. And yeah, definitely when we are in India next, we are going to visit the college for sure.
Okay, Kishan, you have any questions? Kishan is one person from my team. Sangamon team is the only person outside the SME team college. Kishan, you have any one chance to ask one last question?
No, sir.
Okay. Okay, thank you, Soumya. Thank you, Aditya, for your wonderful time. Do
Thank
visit
you.
us, as early as possible. Okay. Mm.
All good.
Yes.
Thanks, everyone.
Yeah.
Thank
See you all.
Thanks, everybody. Bye. Mm.
Thank you.
Bye. Mm.